All right, if you're an instrument pilot, you already know technology is a total game changer. Today, we're going to dive deep into one of the most important tools in any modern cockpit, the RNAV approach. We're going to break down exactly how your GPS can guide you nice and smooth all the way to the runway. I mean, think about it. Imagine this. You're in the soup, visibility is pretty much zero, and you've got to get on the ground safely. That's the real challenge of instrument flight, right? But what if your GPS, the same kind of tech that's in your car, could create this perfect virtual highway in the sky, leading you right to the runway threshold? Well, that's exactly what RNAV is all about. So let's get into it. You see, getting a handle on RNAV isn't just about learning another procedure. It's really a whole new way of thinking about navigation. So our mission today is to tackle this head-on, to master this critical skill, and ultimately make our flying that much safer and more efficient. To really get why RNAV is such a revolution, we gotta rewind a bit and look at the old-school way of doing things. For decades, we relied on these ground-based radio beacons, things like VORs. But they've got one major weakness. Radio waves need a clear line of sight. That means things like mountains, big buildings, heck, even the simple curve of the Earth can block that signal.
And that is where RNAV, which stands for Area Navigation, by the way, completely changes the game. It's a technological leap that totally reimagines how we get from point A to point B, and it solves that whole line of sight problem once and for all.
I mean, just look at the difference. It's night and day, right? On the left, you got the old way, this clunky zigzag from one ground station to the next. But on the right, you have the new way, a straight, direct line between virtual points in space, all thanks to GPS. It's not just way more efficient, it gives us global coverage and frees up airports from having to maintain all that expensive equipment on the ground. So what's the magic behind all this? It's the waypoint. A waypoint isn't a physical tower on the ground. It's just a set of coordinates, a specific latitude and longitude. Think of it like a pin you drop on a digital map. And because they're virtual, we can put them literally anywhere, creating this incredibly precise and flexible highway system in the sky. Okay, so a great way to think about all the different RNAV approaches is like having a toolkit. Each tool is designed for a very specific job, and which one you use depends on the weather, the airport you're going to, and the equipment you've got in your panel. So let's open up this toolbox and see what's inside. Basically, all RNAV approaches boil down to two main families. The first family gives you lateral guidance, that's your left and right. With these, you're the one in charge of managing the descent. The second, more advanced family gives you both lateral and vertical guidance, so left, right, and up-down, creating a beautiful, smooth guided path all the way down. All right, let's grab our first tool from the box. This is the one you'll see most often, the LNAV or lateral navigation approach. Think of this as the trusty workhorse of the RNAV world. It gives you that essential left-right guidance to get you lined up with the runway. So with an LNAV approach, you're the one managing the descent. You'll do these step-downs, flying to a certain point, dropping to a new, lower altitude, and then leveling off again. You fly down to what's called a minimum descent altitude, or MDA, and then you hold that altitude, flying toward the airport until you either see the runway or you have to go missed. And the best part? You only need a basic IFR-certified GPS, so tons of airplanes can fly them. Okay, now for the real heavy hitter, the precision tool in our kit, the LPV approach. That V is for vertical guidance, and trust me, it is a complete game changer. It gives you a guided path both horizontally and vertically, like a virtual tunnel leading you right down to the runway. People call LPV the gold standard for a reason. Its precision is just incredible. So what's the secret sauce here? It's something called WAS, the Wide Area Augmentation System. You can think of it as a supercorrector for GPS. It uses ground stations to fine-tune the signal, making it so accurate and reliable you can fly down to minimums as low as 200 feet, just like a classic ILS. And with an LPV, you follow a continuous glide path down to a decision altitude, or DA. That's the point where you make the call. Runway in sight, landing, or going missed. Okay, theory's great, but how do we actually do this stuff? This is the fun part. Let's walk through the mission of flying an RNAV approach, step by step, from start to finish. Every successful flight starts on the ground, right? Your briefing is absolutely critical. This is where you build that mental picture of exactly what's about to happen. You got to study the chart, know your waypoints, memorize your altitude restrictions, check your minimums, and know that missed approach procedure cold. You've got to have this stuff down before you even start the engine.
Next, you take everything from your briefing and you punch it into the box. You're telling the avionics exactly what you want to do. And I can't stress this enough. Cross-check everything. I mean, every single waypoint, every single altitude. Check it on the screen against the paper chart. A simple fat finger error here could be a really big deal later on. Check it, and then check it again.
All right, now we're airborne and the magic is happening. You're following your CDI, that needle that tells you if you're left or right of course. You're hitting all your altitude restrictions, and most importantly, you're staying ahead of the airplane. A good instrument pilot is always thinking about what's next, anticipating the next turn, the next descent. You're not just reacting, you're commanding.
And this right here is probably the most important rule in all of instrument flying. Going missed is not a failure. Let me repeat that. Going missed is not a failure. It's the mark of a smart, disciplined, and safe pilot. If you're ever unsure, unstable, or just not feeling right about the approach, the safest and smartest decision is always to power up, clean up, and climb away. So we've seen just how incredibly powerful RNAV is. But how does it really stack up against the old, traditional systems we've been using for decades? Let's put them head-to-head and see how they compare.
Just look at this number. Over 4,100. That's how many LPV approaches there are in the US alone. I mean, that's just a huge number, and it tells you everything you need to know about how vital this tech has become. And this chart really drives the point home. You've got over 4,100 LPVs compared to around 2,000 of the traditional ILS glide slopes. That's more than double. RNAV isn't some future thing. It is here right now, and it's the dominant system. But, and this is a big but, this doesn't mean we just toss out the old systems. While RNAV is amazing, what happens if there's a GPS outage? Suddenly those tried and true, simple, familiar systems like an ILS or VOR, well, they become your lifeline. They are a crucial backup. They both absolutely have their place in the modern cockpit. So there you have it. We've gone from the old school limitations of ground-based radios all the way to the incredible precision of satellite-guided landings. You've got the tools, you understand the mission, you've really got the fundamentals of modern navigation down. The only question left is, with this powerful skill now in hand, what will you master next?